Humanity is heading back to the moon, and this time we're actually going to stay. But as you can probably guess, turning that grand expectation into reality is, well, it's incredibly complex. Welcome to this explainer, where we're going to unpack NASA's highly intricate and recently updated Artemis roadmap. We'll be breaking down the actual hardware, the massive budgets, and some pretty sobering safety realities that are going to dictate exactly how and when our astronauts return to the lunar surface.
So, here's our flight plan for today. First up, the return to the moon. Then we'll look at the landers and next-gen spacesuits. After that, schedule delays and realities. Fourth, mitigating astronaut safety risks. And finally, we'll cover the revised Artemis roadmap. Let's get right into it.
Section 1. Return of the Moon. Now, unlike the Apollo days, our modern approach involves some serious, escalating complexity. We aren't just doing a quick dash to the surface and heading home. Think about it. Artemis I was an uncrewed test. Artemis II will be a crewed flyby. And as we ramp up to Artemis III, IV, and V, we're introducing the Gateway Space Station, lunar rovers, and sustained surface operations. Basically, NASA's building essential muscle memory. See, a major flaw with older plans was a launch cadence of maybe one mission every 3 years. That meant you had to rebuild operational muscle memory with literally every single launch. But this new, step-by-step escalation, it's designed to keep that momentum going strong.
Before we look at the incredible new hardware being built for these missions, we've got to understand exactly where all these vehicles are going to meet up out there in deep space. It's called Near Rectilinear Halo Orbit, or NRHO for short. This is a highly specific 6.5-day orbital path influenced by both Earth and lunar gravity. It's an incredibly eccentric path. Imagine swooping in as close as a cross-country road trip, just 1,000 miles from the lunar surface, and then swinging way out, past the circumference of the Earth itself, to 43,000 miles away. Pretty wild, right?
This specific orbit is absolutely vital because it actually gives us about 55 opportunities a year for landers to head down to the lunar surface. NRHO is the exact point in deep space where the Orion crew module, after traveling all the way from Earth, will rendezvous and dock with the massive human landing systems waiting in orbit. From there, the astronauts will transfer over and finally descend to the moon.
Section 2. Landers and next-gen spacesuits.
Now, what's really fascinating here is that NASA has contracted commercial giants to build some truly colossal landers. We've got SpaceX developing a modified version of their Starship, which, to put it in perspective, is essentially a 16-story skyscraper landing on the moon. And then we have Blue Origin creating their Blue Moon lander. These aren't just your standard transport vehicles. They're actually designed to double as living quarters for the astronauts while they're on the lunar surface. It's this completely tailored approach where NASA sets the high-level safety requirements, but then they rely on commercial industry to innovate the actual solutions.
Okay, so once they land, the astronauts obviously need to step outside. Let's walk through the incredibly intense, multi-step testing process for Axiom Space's new XMU spacesuits. These things are designed for ultimate mobility at the harsh lunar South Pole. First off, they undergo elevated suit pressure testing to see how well crews can actually move and perform tasks under intense physical resistance. Second, they get dropped into a 40-foot deep pool at the Neutral Buoyancy Lab to simulate the moon's 1/6 gravity. And finally, they use the Argo's overhead lift system to practice actual reduced gravity moonwalks. Get this, they have already logged over 850 grueling hours of pressurized testing. Amid all these dense engineering specs, we have to remember that real humans are the ones stepping out into the void. Laura Kearney perfectly captures the passion and the absolute necessity of safety driving this whole thing. She says, "This achievement reflects our shared commitment to deliver a safe, capable lunar spacesuit that will enable astronauts to explore the moon's surface." That commitment is what literally drives every single engineer on this project.
Section 3. Schedule delays and realities.
To really grasp the pressure on this program, we have to look at the financial stakes. Since 2019, NASA has already obligated a staggering $6.9 billion just for the development of these human landing systems. And they estimate spending up to $18.3 billion through the end of the decade. That is a massive amount of money.
Out of that massive pie, SpaceX's contract value commands $4.3 billion. This chunk of funding is specifically to drive the rapid development and delivery of their Starship lander for both the Artemis III and Artemis IV missions.
But to make sure we've got a backup, NASA awarded an additional $3.1 billion to Blue Origin. This provides an absolutely crucial, redundant landing option for Artemis V. While competition definitely helps keep costs in check, managing two massive commercial contracts of this scale simultaneously is an incredible logistical undertaking.
So here's where expectations kind of hit a wall. The original plan had Artemis III actually landing on the moon, but jumping directly from a flyby mission all the way to a lunar landing without testing the lander with a crew first, while that was ultimately deemed far too risky. So the updated plan inserts an Apollo 9-style test. Artemis III will now serve as a risk reduction mission to evaluate the crew-lander interfaces right here in Earth orbit. That means the actual return of humans to the lunar surface has been pushed back to Artemis IV, which is currently targeted for early 2028.
And honestly, even that 2028 target is under immense pressure. Why? Because of some major technical hurdles identified by the Office of Inspector General. Look, SpaceX's Starship requires unbelievably complex logistics. Because it's so massive, it needs in-orbit propellant aggregation. That means up to 12 Starship tanker flights have to launch, chase each other down, and transfer fuel to a depot in low Earth orbit before the actual lander can even head to the moon. It is a mind-boggling logistical ballet. Because of this sheer complexity, the OIG noted that Starship is not going to meet the original 2027 timeline, and SpaceX's own internal timelines suggest the earliest crewed landing might actually slip to September 2028.
Section 4. Mitigating astronaut safety risks.
Now, these aren't just simple logistical schedule slips. We are literally talking about matters of life and death. Deep space is incredibly unforgiving, and the lunar landers carry the highest probability of crew loss in the entire Artemis architecture, which forces us to ask a really high-stakes question. What happens if a catastrophic event occurs on the lunar surface?
Well, the Inspector General's report laid out some very sobering safety warnings that we need to look at objectively. First, they pointed out missed opportunities to fully apply NASA's test like you fly principles during uncrewed demonstration missions. Second, there's actually an ongoing engineering disagreement between NASA and SpaceX over whether the lander meets the intent for manual flight control, which is absolutely essential if the automated systems happen to fail. On top of that, current crew survival analyses don't account for extended survival once an immediate threat is over. And perhaps most alarmingly, if astronauts encounter a life-threatening emergency and are stranded on the moon or in space, NASA currently has a complete lack of rescue capabilities.
Section 5. The revised Artemis roadmap.
To mitigate these severe risks, NASA isn't just standing by. They are actively embedding their own technical experts directly into the production lines of both SpaceX and Blue Origin. They're using what they call an insight and oversight model. By sharing NASA's decades of hard-won safety expertise right there on the factory floor, they're hoping to ensure quality, drive performance, and make sure that this revised, repeatable architecture actually hits that 2028 landing target and does it safely.
Which brings us to our final thought. We've got the incredible hardware, the massive commercial investments, and a newly structured, safety-focused roadmap. But with the immense complexities of orbital refueling, spacesuit testing, and managing deep space logistics, we have to ask, will the revised 2028 lunar landing hold, or is the exact timeline for humanity's return still written in the stars? It is a fascinating tension between our grandest ambitions and strict logistical reality. You're definitely going to want to keep an eye on those test flights because every single launch brings us one step closer to the answer. Thanks so much for joining me for this explainer, and keep looking up.